Good morning, everyone, and welcome to our webinar. This webinar is on classic versus serverless, having to do with all things Databricks and to learn about their latest innovations. If you have not met Blueprint before, we are a part of the Blueprint team. Blueprint is a technology solutions company, and we do everything from strategy to execution. And if you would like to learn a little bit more about what Blueprint does, you can always visit bpcs.com to learn more about that. We were also named Databricks' Data and AI Governance Partner of the Year just in June. So that was very exciting news, and we love doing all things with Databricks as well. So if you have further questions about the partnership that we have with Databricks or anything around Databricks solutions, we have a great team that can help answer questions like that as well. This is our first webinar on this topic. However, we do have quite a few webinars lined up around Databricks, around the Unity catalog. So please do keep an eye out on our social media to learn more about what events we have coming up that you can sign up for directly on those platforms as well. So without further ado, I will give you guys a quick update on how the flow of this webinar will go, and we will kick things off. So if we haven't met, my name is Ruthie Senanayaka, and I work here on the marketing team at Blueprint and have for a little over 5 years now. And so we will kick things off with Corey and Steve. Corey will give us a quick introduction about him and then pass things on to Steve. And right after that, you are welcome to add in any questions that you want, no matter what platform you are watching on. If it is, Facebook or LinkedIn, Twitter, YouTube, we are so excited that you decided to join us. So it's as easy as adding a comment in the chat box, and we will see your question come through, and I will pop back on and ask our awesome presenters who would like to take those questions. And we want to make this as interactive as possible. So please do communicate and ask questions along the way. And I think that is it. So Corey, feel free to kick things off.
Yep, thanks, Ruthie. And hey, everybody, thanks for joining us today. I'll kick us off, and I'll try to be pretty brief in some of these intro slides. Today we're talking about classic and serverless. I'm sure we've all been watching these announcements at Databricks. We've got some exciting new features coming out. So let's see how they measure up to everything else and what kind of scenarios we can hope to be using them in and get the most value out of it. I've got a little slide here. I'm not going to spend a lot of time on it. We're Blueprint. We solve cool problems. We love doing it. We love specifically finding value for our clients. We've been Databricks partners for, I think, over 8 years or something, multiple awards and all that in that time. So yep, we love this stuff. Love diving into the guts and the deep parts, technical parts of Databricks and how to do it the right way. So you haven't met me either. So I'm Corey. I'm Director of Tech Delivery at Blueprint. Various responsibilities. My background's more traditional in math, science, and computing, research and publications, things like that. I've got various experience from DoD, DOE, agriculture, retail, tech, all kinds of stuff. And yeah, my job at Blueprint is guiding our technical teams through difficult problems and how to solve them the best way we can. And I'll hand it over to Steve to do a quick intro there as well.
Sure. Thanks, Corey. So 35-year professional in computing, engineering background, electrical, Purdue University, also have MBA. I'm almost always focused on how an implementation helps people do well, right? And that's make a positive impact out of these things. This stuff is all about our lives, right? So that's what I'm always focusing on. Corey, I think I need to ask you to advance slides when the time comes. Okay, please, the next slide. Okay, so thank everyone for joining us today. Here's an agenda. We're going to ask a few questions. These are just a little bit that we can get to know you as well as you're getting to know us right now. Then we're going to try to describe the difference in architectures as Databricks is a solution to host to run workloads on classic clusters versus serverless clusters. And then we'll go into the new features. So last week, Databricks announced that they are really uncovering serverless with a whole bunch of new features. It's really kind of exploded upon the scene. Serverless as a SQL data warehouse has been around for 14 months or so, but now they've really uncovered the things for public preview, which is exciting stuff to hear, cutting edge. We'll have more to talk about comparing the two, Classic and Serverless, give some recommendations that we believe right now are the right way to move your workloads from Classic to Serverless. If you choose to, I just want to emphasize the point, Classic is not going away, right? You'll still have it if you need it, if you want it, right? But we have some recommendations of how to move with Serverless, which has a lot of good places where you can. At the end, we'll have a discussion what the future of serverless and big data analytics and the QA at the end. And if you don't have anything more, Corey, next slide, please. Okay, so the icebreakers. We get to know you a little bit like you're getting to know us. So I hope you enjoy these questions. What we're going to ask you to do is in the comment section to the right, probably on the right on your screen, just post your answers. And they're really one keystroke answers. One of them is a little free-form text, but here we go. If you're ready, we're ready. Ruthie's going to be collecting your answers for us in the background. Next slide. There we go. Number one, type a 1 in the chat if you're currently using serverless. If you're not, you don't need to chat. But if you do want to answer, just type a 1 and give you a moment for that. Thank you, Nathan and Sendip. Corey, come on. It's okay. Well, very good. There's a moment. If you want to answer, go ahead. Answer as we go to the next slide. So people are using serverless, have been able to in SQL Data Warehouse for about 14 months, but now they've unleashed the covers. If you've been watching the announcement, you'll see that there's some new features. These new features are workflows and notebooks executed on serverless now, and whether we can use serverless to reduce costs, reduce our overhead of managing clusters, getting our efforts divided. Increasing performance is a promise for serverless, right? And you don't have to manage that yourself. And then the last option here, number 4, being able to focus on delivering business value instead of having your time divided. I'll give you a moment for your answer. Oh, God. Oh, thank you. We might have a lag on the comments, so let's go ahead and move forward, I would think. Thank you also, Nathan. So if you're not in serverless, you're hearing about it, if you would just drop a line or two as to why you're hesitant to get into serverless, if you want to respond. Of course, we'll probably have to go for a moment more on this one because it's free-form text, right? So. I would guess we might want to move on to the fourth and funnest question. How do you feel about your clusters, A or B? Yeah, there certainly is a lag in the comments versus when the comment is entered and when we get to see it. So appreciate your patience. Thank you, Nathan. Sometimes I feel that way too. It was just a joke question anyway, right? So thanks for your respondents. So I guess we would move on. So this slide is showing kind of a holistic progression, evolution of cluster compute from the beginnings of times on the left, where you would buy this hardware, you would stand it up in your own office data center, you'd manage the clusters yourself. The provider really had the responsibility of providing a warranty to you, and that was about it. But then things evolved, as they tend to, and then the advent of something which I think is almost a miracle to computing, which was virtualization. Virtualization took the responsibility of the hardware off our shoulders and moved it to the cloud and gave it to people who are much more capable than me in a small shop of managing that hardware for me. So Azure, AWS, GPC are much better resource at maintaining hardware than I am. It also gave the provider the responsibility of deploying it. And since I'm not buying hardware, I no longer have warranties, right? So that evolved because Azure, AWS, the rest, they saw we have these clusters we're providing to you. We can manage those clusters for you. A whole new SKU, a whole new business opportunity is managing clusters for clients. So now the provider is doing scaling for you. And of course, as business is, the more someone does for you, the more they have a right expectation to incremental more profit for them, right? So, but that's good, right? Because if they scale out properly, they can manage clusters for a whole bunch of customers for less than I could for myself. But then now we get to serverless, which is almost a paradigm shift, because you think of the benefits of virtualization technology like Kubernetes. There comes the realization that really I'm asking to do some processing. I no longer have to think about hardware or operating system. I just send my job off to a serverless cluster. It does the job and I get the benefit. And I don't even have to worry about upgrading operating systems or when that might happen, or hardware change outs and whatnot, refreshes. I am at this point, which is what I love, that I'm only focusing on the code I write, delivering a solution, providing business value. I'm not dividing my time between other activities like managing clusters at a lower level. This kind of an interesting point is that Databricks really only came to Azure as a service, available as a service, November of 2017. We've been doing clusters since classic clusters since that time, where we go to Databricks website, we get a workspace, we configure what we want, and then we tell Databricks with a mouse click to execute. And what Databricks is doing is they're sending everything they know we've asked to like Azure in my subscription, doing my work and getting me the response back. And that cluster stays up and running. Serverless is a paradigm change. Once the job's done, that cluster is gone, it's destroyed, which is a very simple thing to do in a Kubernetes environment, for instance. It could be any virtualization, but very simple to do in Kubernetes environments. You just basically destroy the instance. And that's what they're doing. Next slide, though. So here we're going to talk about, try to represent how the Databricks as a solution, as a service, as an architecture, what's different between classic and serverless. Next slide. So the image on the right-hand side is really the focus for me at the moment to speak to. So there we are as users on the left-hand side of the right-hand image. We're interfacing with our account on Databricks to set up configurations and to hit the submit button for our job and whatnot. And what Databricks is doing on the backside is they're sending all that information over to my account on Azure, for instance, or AWS or GCP. And they tell the cluster to start, so that when the cluster's up and running, then they tell the running cluster to run this workload that I'm asking for. That startup time takes quite a bit of time. It literally is like starting a new computer from cold turn off first time out of the box. So it takes a bit of time. And there's been a lot of things that have been done to try to minimize that lead time of starting a cluster. And the concepts really come around to like serverless. So now let's look at what's different in the next slide. Serverless, what's different is I'm still integrating with the workspace through Databricks website, right? But Databricks on their backside in their cloud account, same cloud as my Databricks account, they're managing, they have the compute. It is their compute that you're running. You're submitting the job to their compute. So in a very short order, what happens is I submit the button to submit my job. They're finding in their pool a server or servers for a cluster to configure them for my network, for my workspace, for my storage in a very short amount of time, and then start running my job. So, but they can do that because in their environment, they have all these machines up and running in the cloud. So they're not actually starting something. It's already started. All they have to do is a little bit of configuration change to get to a point where they're running my workload. So the next slide is really, I'm just bringing back the image for the classic. So you can see kind of the difference, classic and serverless in one shot here. In classic, it is your resource in your subscription on your cloud provider. In serverless, it's Databricks resource in the same provider as you. And they just have all their customers, they have all these machines ready to run as clusters for all their customers' workloads. And so it's just very simple for them to manage these things and stand up and run your workload very quickly, as opposed to you starting from cold, bare metal, basically. Next slide. So this list here is, I don't want to read through the list. It's some good comparison. I assume everyone's going through the list themselves. But what I like to think about here, again, is that aggregation of compute on the Databricks cloud account. That really is an incredible business model. It's an evolved business model for the cloud, because now Databricks is kind of a volume discount reseller of compute in your cloud, right? And as a volume discount reseller, they're doing more for you. Since they're doing it for more, they should get an incremental more profitability for that service, but you should get a discount overall for what you're doing because you no longer have that compute resource in your cloud subscription. I think that's beautiful. One thing I really enjoy about this one thing here is the maintenance, right? Minimal maintenance required under serverless. Well, what they're saying is today is the last day that you ever upgrade. So they're constantly doing that for you, right? Keeping you up to where you need to be. Startup time is near instantaneous, right? And we'll go into that a little bit. But if you think about, if you're familiar with SQL Data Warehouse, you submit a job, it starts a cluster 9 seconds, it starts running your job, right? But to the last point here, cost model. Next slide, and I'll hand this back to Corey. But what I want to mention here to introduce Corey is Corey's the father of I don't want this to be pitchy, and it's not meant to be. Corey's the father of a product that Blueprint offers. It's called Lake House Optimizer, or LHO. What LHO is, it's something that we built that we offer freely to clients with engagements. What it is, it's a tool that helps us help you. One of many aspects of this product is it reports on costs, helps you get an idea around where your costs are, and helps you understand where you might save on costs. For LHO, serverless is kind of a new thing too. We're still doing well with that. But in the cost construct, Corey has done a lot of work to understand the serverless costs and used LHO to figure that out. So Corey, tell us what you find. Thank you.
Yeah, sure. And thanks for the handoff there. Yeah. The cost model is really interesting to me. We at Blueprint, we work with a lot of clients of different scale and sizes, and a consistent question across all clients is, how do I know I'm using my Databricks dollars the best way, right? So introducing serverless has some really cool new ideas, but it also changes how we think about cost of things we do, which means choosing the right tool for the job you're doing in Databricks changes a little bit too. Not in bad ways, but exciting new ways. If you like shiny new tech, this is a good time to be working in Databricks. So, kind of picking up from the cost model, just conceptually, let's talk a little bit about the difference in cost model with Classic and Serverless. Classic cost model is basically two terms. You have what you pay Databricks plus what you pay your cloud provider like Azure or something. If you haven't looked in detail before, here's an example of what that can look like, where, and you'll see little screenshot snippets like this. I just put run LHO because so you know where these kind of views come from. This is how we do this work with all of our clients. If you really want to dig into this, it just takes a tool like this. So yeah, I'll just show you the ones I used for the analysis that we'll go through. But yeah, cloud breakdown, a healthy ratio is usually somewhere in the neighborhood of 50-50, right? If you're on classic compute of any type, it varies a little bit here and there, but you'll pay half your bill to Databricks, half to your cloud provider. Again, 50-50 is not a hard rule. 40-60, 60-40, all these numbers are okay. They're pretty healthy. If you skew off of that, you probably got some issues to resolve. But one of the cool things about serverless is that whole cloud piece of your bill in Databricks goes away. So that doesn't mean your bill gets reduced by 50%, because the other change here is the DBU rates for these offerings will be different. So there's just an example here. Interactive serverless compute is about 70 cents per DBU hour, where classic all-purpose compute is 55 cents per DBU hour. So there's a little increase there, but notice it's not 2x, right? So if you're dropping 50% of your cloud bill, or right, I'm not paying Azure for this anymore, and my Databricks compute goes up 15 cents. That's a lot of savings for me, right? Especially as things scale up. So just big picture, high level, these are interesting features that everybody should be thinking about. Where does this fit in to my best practices in my org to make sure we're using Databricks the best way to get the most bang for our buck, right? So we've all been watching, I'm sure, I grabbed this slide right out of Data and AI Summit, right? I'm sure we've seen this. They're Databricks 100% serverless. There's all kinds of features that are serverless now. They're all valuable in different ways. Just to list through them real quick, Mosaic AI, that's referencing things like training ML models, serverless model inference, so serving a model with like API endpoints. Notebooks, this is a new one that we're going to talk a lot about today, this interactive use of serverless compute. Databricks SQL, like we mentioned, classic SQL warehouses versus serverless, they've been around for a little while. A lot of the arguments from those and those learnings that we've got over the past year or so do translate to all-purpose clusters, not identically, but we'll talk through some of that. Dashboards, serverless options, we've got workflows now. So I think I've been in Databricks too long, and I still call them jobs, but workflows, this idea that you can schedule a thing without the 5-minute let's go get resources is a big change to a lot of how you can use Databricks now. And we'll talk through some of that in detail. And then of course, DLT pipelines, having serverless options now. It's just the whole thing. It's all available. You can go serverless if you'd like to. And to reiterate what Steve said, Classic can't go away anytime soon, if it ever will. So that's not the scenario when it's more of there's a new feature, a new product, you can make a decision, Classic or serverless on a lot of these now. So let's talk a little bit about the two. We'll go into detail in this talk. And I do want to preface this. I'm a bit nerdy. I like to geek out on this stuff. Some of the stuff I present will get a little bit technical, but I will summarize each section with here's the takeaway. So if you aren't super interested in the how and why, that's fine. You will get that summary, and you'll be able to walk away from this webinar with some new best practices to take with you to your team. But yeah, starting with serverless notebooks. Here's their new little logo from Data and AI Summit. Interesting, cool. Doesn't look like a notebook from what I'm used to working with in the platform, but it's cool. We got one. But what are the common use cases of these serverless notebooks, which the classic version was all-purpose compute, right? This is the interactive use of Databricks clusters. So think of things like analysts, data scientists who are doing ad hoc analytics. Maybe a business user has asked, hey, what happened to our sales yesterday? Somebody help me figure it out, right? You're going to jump into an all-purpose cluster or a classic SQL warehouse or equivalent, right? And you're going to query tables, do some analysis, maybe write some Python code to evaluate some algorithms come in, maybe some plotting. Really this interactive use for like a one-time run of something. I just need to answer a question. Another, maybe even the primary use in a lot of orgs is development work. So when you're writing your, say, data pipeline to ingest data from, I don't know, some weather API or whatever you're working with, your development work being in a notebook means you're doing that work on an all-purpose compute cluster. So every time you type a line of code, hit enter, look at the result, maybe you got a bug, you need to fix it. So you go back, you type some new code, hit enter. This is all that interactive use and one of the primary use cases for serverless notebooks or all-purpose compute being kind of competitive features here. The other one that we're going to talk about today is workflows. So what are some common use case scenarios for workflows? It's kind of the opposite, where interactive is more like my code changes a lot from run to run. I may only ever run this thing one time and never run it again. Where workflows are things that are saved to be run again in the future. So scheduled, triggered jobs. Common ones like this are like the data ingestion and transformation pipelines, which most companies that get into Databricks have a ton of these. Whether it's, hey, I've got a task in my workflow that grabs data from an API. I've got a subsequent task that is going to transform it a bit and drop it into a bronze table. Subsequent is going to do some transforms into silver table. Subsequent for gold layer, right? You tend to have a lot of tasks or jobs or workflows or all of them around data ingestion and transformation. But more than just that, right? There's all the data science ML space where you're training models. These are often saved recurring jobs. Monitoring drift and data for any models you have in production. This is something you usually save like this and rerun many times. Refreshing BI data, all these things, right? If you can imagine a scenario where you probably want to go run that code again, then workflows are where you probably want to do that. And for reference here, we've got the dollars per DBU hour listed for the top one is what they're calling the serverless automated serverless compute. So this is jobs compute, that's serverless. And then classic jobs compute is below it. Very interesting thing to point out here is serverless right now is cheaper than classic jobs compute, in addition to all the other benefits that it has. So this is really significant. I did confirm with Databricks that this is promotional offering. So this price will change in the next few months. I don't remember the exact date. We can look it up. But today, serverless compute is cheaper than jobs compute. And as we look through results later, you'll see even after the promotional discounts are accounted for, serverless compute is still going to often beat out total cost for jobs compute, which is what makes a lot of this so exciting. So I'll just dive in. So let's talk about classic versus serverless, some common scenarios and solutions. In order to talk about this, we need a little bit of a framework of understanding of the cost and value of a Databricks cluster that you're using. So we like to think of it, and when we talk to our clients about this, clusters have essentially three states. And you can track a lot of this in things like LHO, which is why we've got another snippet here. But the first state is when you say, hey, cluster, I want to run code. The cluster has to start. We're thinking classic right now, right? With the red little bubble at the bottom left. Hey, cluster, turn on because I want to run code. I'm sure you're very familiar with this, especially if you've done development in Databricks. That usually takes about 5 minutes as a rule of thumb to say, hey, cluster, turn on. 5 minutes later, that's when it will be ready to run your code. So that's actually pretty low value for us as a Databricks customer, right? To pay my cloud provider to turn those VMs on and, provision them, get them ready to scale up and everything, deploy Spark, have everything set up. So when I say run code, it can. It takes about 5 minutes to do all that. And you do pay your cloud provider for that time. So we call it a low value time because you're paying for it, but your business isn't getting any value. You're not computing anything. There's no insights to be had. It's just setting up infrastructure and paying to wait. So yeah, it's just been part of life for a while. The second state is this active state, which we would say this is the high value piece of using a cluster in Databricks. This is where it's running your code. So maybe I'm an analyst trying to figure out what happened to my sales yesterday. What do we need to fix, right? You're gaining real insights. You're generating revenue generating insights, or maybe you're calculating some optimization to drive a decision for something else. The actively running code is where you get value from your Databricks clusters. Now, these are interactive clusters, right? So the nature of interactive clusters is that between running code, you have periods of idle time. So let's say, for example, I jump in a notebook, I write some code, and it generates a plot. Well, that plot means I'm going to sit here and scratch my chin and look at it and think about, what does this mean? What do I do next? And then I have an idea. I start typing a little bit more in a new cell, write some new code, and I hit enter. All of that time between running code, you do still pay. And the difference about these idle times from startup time is you do pay Databricks for that as well. So you pay cloud and you do pay your DBU charges for idle time on these all-purpose clusters. So again, the resource itself, the cluster, is not providing value to you at this time, but you are paying full price for it in these idle scenarios. And then this last one I point out specifically, which is what the caution symbol there is for. Idle time is less straightforward about the value that it adds. You get into opportunity costs and the cost of progress within an org, things like that, when you start considering things like idle timeout policies. And we'll dig into that a little bit here in a second. And this snippet here from LHO is representative. The reason I show it here is it's kind of hard to see. You're not supposed to look in detail, but it spikes with lots of periods of inactivity between. This is totally normal. This is what development looks like in interactive clusters. Go to any client that uses Databricks in any scale. It always looks like this, and it's not because it's being misused, right? This is just what development looks like. Development is not running code. Development is writing code, analyzing results. So if you have idle time, that's okay, that's normal, right? I just wanted to make sure we pointed that out, that having inactivity on your cluster doesn't mean you've made a mistake. So all that to say, there are periods where you don't get value, and there are periods where you do. And what's so exciting about serverless is, if you check out the timeline at the bottom with the boxes, serverless means you don't pay for that anymore. You literally only pay for the part of your usage that actually generates value for you. And that's, a godsend, right? This is what we've all been asking for years and trying to come up with hacks on how to work around, right? This is honestly what gets me excited about all this is the solution users wanted, and it happens to benefit us tremendously and benefit Databricks, which is what makes a feature like this so cool.
And Corey, I just want to hop on super quick because we did get a question around what you just spoke to. I'll pop it up on the screen as well so that you can see it. But it says, so are you saying that automated serverless compute is less expensive than jobs compute?
Yes, today. So this is, there is a blog post. Let me see if I can grab a link. They released a blog post on Monday announcing general availability for all of these serverless offerings. And within this blog post, they do explicitly call out that there are promotional discounts for the next month or two on these offerings. So today, yes, automated serverless is less expensive. After the promotional discount, the dollars per DBU hour will be higher, but you'll still, as you'll see in the results here in a little bit, it still beats out in some scenarios that are pretty powerful.
Thank you.
Good question. Yeah, I asked 3 people in my company to double check that I was reading that right, because I didn't believe it myself. I had to go to Databricks before I really believed what I was reading in the documentation and cost was accurate. So yes, good question. Okay, so let's jump to the next one. So this is where we're going to get potentially a little bit technical. If you like that stuff, cool, let's have fun. If you don't care for it, you got some cool summaries we'll go through. But first, let's talk about notebooks, classic versus serverless. So a really common scenario we see is excessive idle times. So this is another just screenshot taken out of LHO where the idle ratio is shown for every interactive cluster. And something you really quickly see is, wow, 97% idle, and you paid for all of that. 82%, 86%. I don't know how else to say this other than this is normal, right? 97 is a little bit high, but 80 plus is super normal for interactive clusters. So when we think about this, right, you can go the classic sysadmin from your on-prem Hadoop clusters years ago or something. They're going to be held to metrics like system load or utilization metrics in general to justify, hey, we spent a lot of money on this cluster. Show me that you're using it to justify what we paid for this, right? Or what we continue to pay to maintain it. The same arguments come around for these interactive clusters. You're telling me 80% of what we paid for gave us no value, right? So as you go higher up in like the FinOps space, that question will come up. Now, for an easier to follow example, right? We've all heard this from parents at some point. So I just grabbed a meme off the internet. You don't want to pay for the lights being on when you leave the room. So turn them off, right? So do you want to pay the bill just for lighting a room no one's in? Of course not. It's the exact same argument, but it's something that you haven't been able to really get around well in Databricks. And this isn't a uniquely Databricks problem. This is just, hey, you've got a cluster that's ready for you. Somebody's got to pay for that to be ready for you. So over the years, there's been various solutions to try to bring this idle ratio down and minimize what you're paying for those low value periods, right? So the super naive old solution that you see a lot of is, well, we'll just implement really aggressive timeout policies. So like you see at the bottom here, hey, terminate after 10 minutes of inactivity. And you know what? Everyone who does that will immediately see in their next Databricks bill that costs go down. That does work. But the reason we call this naive is you've shifted the cost somewhere else and you've made it bigger. What happens when you're, highly paid data engineer or data scientist is sitting at their computer trying to run code, and every time they try to run more code, they have to restart the cluster because it timed out again. Well, you're going to have 5 minutes of at least $50+ per hour resources checking their phone, hopping on social media. You're lucky if they maybe hop into Slack and send a message or something. 5 minutes isn't enough time to context switch. So you get frustrated developers, you get opportunity cost lost where they could have just run this code, but now they're waiting instead. And it really just accumulates in harder areas to measure. So I do not recommend super aggressive timeout policies ever anymore, but this is a pattern we've seen in a lot of places. But other solutions, right? You can get more advanced. Something we've done is we do user behavior analysis. We just use LHO to see how do people use this cluster. And then we can optimize a timeout policy specific to that user behavior, accounting for opportunity cost as well. We don't have to go into the details here, but you can see the difference between really naive solutions is really quick optimization, really quick idle timeouts, 10, 20, 30 minutes. But if you account for opportunity costs, it quickly jumps up to about 300 minutes or so, even for, say, 100K salary developers, which is, these days, not a real high salary in a Databricks environment, right? So there's old solutions, but now with these things GA, there is a much easier solution, and it's just use serverless. So what we have here, we ran some tests and we brought a little bit of data to say, let's do a head-to-head comparison. So the scenario we're looking at here is, as an analyst, I've got a notebook that I want to run. I'll kick off that notebook, which I know it takes a few minutes. So while it's running, I'm going to head to my meeting. And when I get back, my results will be there. So, classic compute scenario, the cluster will time out when it's time. I'll have my results. It's fine. So the way we did the simple experiments here, hey, let's just take the exact same code, run it on both classic and serverless 15 times each. We'll track all the costs and runtimes and everything in LHO. And then we'll just report on, where did the savings come from? And to try to help classic win out a little bit, stay a little bit closer and competitive, we did use an aggressive timeout policy on those clusters of 20 minutes. And even with an aggressive timeout policy, the results are really clear. By not paying for those idle times, both startup and in this scenario, startup and timeout, Classic came up to about $2 per run on just a standard 4 DS4 V2s, right, with a driver node. And serverless came out to, $1.29. It's literally more than a third saved just by saying, hey, run this on serverless instead, so I don't pay for those low value idle periods. Now, if you recall the billing rates that we showed earlier, this is still a little bit high. This is Classic is still 70 cents per dbu hour, and serverless is Classic is 55 cents per dbu hour. Serverless is 70 cents. So cost per unit is still higher on serverless, but because of the lack of startup times and the inherent performance optimizations that Databricks does for you now, serverless actually wins out on the cost in this scenario. So one, your bill is measurably smaller by switching, right? But two, there's bonus costs, bonus value added here, right? There's no more productivity delays. That we're talking about literally interactive development use cases, right? You don't have your high-paid resource who's trying to solve a problem delayed by 5 minutes here, 5 minutes there, 5 minutes again. These aggressive timeout policies often end up in like 10 cluster starts a day, which if you add all this up across developers in your team, you're talking hundreds of hours adding up over the course of months and years. Productivity delays are not there anymore in serverless, and that's a huge part of value of this. But then also, for those of you more familiar with Databricks platform, it takes a lot of effort to really fine tune a cluster. And now you don't have to think about that. You don't need to worry so much about how many workers, what's the VM type, CPU optimized, memory optimized, right? Do I need Photon or not? Do I need to auto scale? Well, what are my auto scale parameters? What's my timeout policy? You don't have to spend time solving those problems anymore either. And that's another savings. It's going to be harder to measure, but in addition to the cost savings you're getting on your bill, it's just cherries on top. So really cool result. Really excited about this feature and seeing results like this. So trying to check the time. I think we got 10 or so minutes left, so I'm just going to keep running through. But let's shift our focus over to workflows. So interactive development, really cool use case, seems valuable. What about scheduled things? So we got some more pictures from LHO here to show just representative data that we see a lot of. And this is one of the most common situations we see in a lot of Databricks users, our clients, is many short workflows, jobs, tasks, however you want to label it. What we often see is as you use Databricks more, you start building more pipelines. Maybe there's a pipeline to ingest from this API, a different pipeline for another API. Maybe there's new jobs or tasks specific to going from raw to bronze, a different task from bronze to silver, a different task from silver to gold, right? Maybe there's a bunch of tasks for training ML models. What you end up seeing, though, is hundreds of scheduled jobs in the platform. And the duration of these jobs is less than 10 minutes. And from what we've talked about already, we know if you investigate any one of these runs, the setup time is close to 5 minutes every time, even for jobs compute, right? So what you end up doing is you're paying for 4.5 minutes of, hey, cloud, get a cluster ready for me. And then you're paying for 2 minutes of run my code. So this scenario is heavily imbalanced on what you're getting value for and what you're paying for. So just to run a few simple numbers to get an idea of the scale of this problem that we see with a lot of our clients is, let's assume 200 jobs, which is not a huge number in this scenario. If you're in the platform, you will get there. 200 jobs. Let's say you've got a lot of them are running hourly, so 24 times a day, and you've got about a 5-minute cluster startup. And let's just call them really simple starter clusters, DS4 V2 times 4, right? That's 50 cents per startup for each one. That comes up to almost $2,500 a day in this scenario that you're paying to start clusters where you're getting no value yet. And then ramp it up to a year, you're pushing $1 million of what is essentially waste. It's idle time, right? So This is not a new problem. This has been around since Databricks has been around. It's not a deal breaker, but we've had various solutions over the years that we've implemented and used and seen clients doing. One of the funniest ones I remember from a while ago now is we'd see a lot of clients, they would just keep an all-purpose cluster on all the time. And at the time, that was the most expensive SKU in the Databricks platform. And they would just keep that thing on 24/7. So when their scheduled jobs needed to run, they didn't have a startup time. This wasn't a cost savings tactic. This was an SLA meeting tactic. They can't be at the variability of their cloud provider to find those nodes they needed quickly enough. They need to be ready now. So it was a very expensive solution, but it solved SLA problems, the business critical things finished on time. Evolution of that was, hey, APCs are expensive. How about a pre-job job, a little warm up for the cluster? So, you'll instead of leaving it on all day, you'll use an all-purpose compute again, and you'll just have a job launch before your 8 o'clock job, maybe at 7:45. Compute some meaningless nonsense to spin it up and make it scale up and really have all the resources available and ready to go, warm cluster. And then it shuts off, and before it times out, your scheduled 8 o'clock job can pick up a warm cluster and do its thing efficiently. So improvement, but still, a little silly. You're paying literally for stretches of the cluster. Databricks came in with VM pools to help solve this problem. So this is a really helpful feature. But what we've seen through time is Databricks doesn't charge you for these, but your cloud provider charges you for every VM that you have idle and quote unquote warm waiting for you. And unfortunately, VM pools don't give you that instantaneous start either. There's still less than 5, but a few minutes of startup because Databricks hasn't taken it yet. So it doesn't have all the Spark config and everything ready to go. So it did reduce startup time, and Databricks didn't charge you for it themselves. So that's cool. But man, really using these things optimally the right way was a massive challenge. There's just too many knobs. How many pools do I need? Which VM types do I need? How many VMs in the pool? What's the timeout policies for VMs in the pool? How do I orchestrate jobs to use which pool? People would set it up and then they just say, hey, it's good enough. I got to stop. I can't get this perfect. So challenging, but it was a cool attempt at a good solution. What we have these days are better still. So with workflows, you can say, hey, I'm going to schedule a couple of jobs to use the same all-purpose cluster at the same time. So there's a risk for resource contention, but at least you're avoiding the startup time on a lot of these. And then my preference is usually, hey, if it's running hourly and it only runs 2 minutes, do them sequentially, right? No resource contention anymore. SLAs are not even close to at risk, and you're only paying 1 startup time per group, which we often refer to this as orchestration optimization within Databricks environments. So a lot of options, but again, enter serverless. You don't have to think that hard about this stuff at all. So let's look at a common scenario we see, the one we're talking about. We have short jobs scheduled to run many times every day. We have important SLAs to meet, but we don't want to spend excessive amounts of time and resources fine-tuning the complicated configurations of clusters and VM pools. So same scenario, we'll run each on 15 times on Classic and Serverless, track the cost in LHO, and the results are wildly impressive. The fact that you can go from about $1 per run down to 20 cents per run is great. And as we mentioned in the chat earlier, right? You are seeing the effects here of promotional discounts on this 80% saved, but even when you take those away, there's still a significant margin of savings here for serverless on this really common scenario we see with a lot of our clients. So yeah, do you want to pay almost $2 million a year to run these 200 jobs hourly, or would you rather pay 300K? Like that's a very obvious choice for most clients. So, and again, there's bonus points here too that are harder to measure. You don't have the resource contention of shared compute, shared clusters. You don't have the wasted time and resources for managing VM pools or ill-defined configuration optimizations, things like that. So a really big win for serverless on the scheduled just workflows and jobs. So I see we're close to time. Quick recommendations we can run through. One, experiment and monitor. All Databricks has released and will continue to release new features. The only way to know which one's best is either to experiment and monitor what's working best where, or use tools like LHO, which can recommend, hey, I've noticed this workflow would be better optimized for serverless compute. Maybe you should use that, right? It's going to take tools or a lot of people, and sometimes both. Sometimes a lot of people will go make their own tool and it just gets even bigger, right? So one, you've got to monitor somehow. Two, I would highly recommend Serverless for interactive notebooks. Where you can do this, you should probably be doing this as soon as you can. Not just for your bill, but for just the overall effects of productivity and just revenue generating code being able to actually run today, right? If you're looking for an easy button, if you got a new project started in Serverless, that's the easiest way to just start experimenting and see how this feels. If you haven't tried it yet on interactive, you're going to love it. It's going to be hard to put it down after that. If you're looking to reduce workflow cost, I didn't go into the details of this, but there's some simple math we've done for LHO as well, where if the runtime of a job is less than about 5 minutes, it's going to be cheaper to run this in Serverless. If it's more than a 5-minute execution time of a job, not setup, but execution, then it's probably going to be cheaper in classic jobs compute. So that's a rule of thumb. The numbers are less exact than 5 minutes, but yeah, the math is pretty straightforward, and the rule of thumb is all you really need. If you're adopting now and you want to go, hey, I want to run something serverless, let's get off this webinar and go do it. I would start with SQL jobs first. It's less likely to need any changes. I prefer Python, but there are some Python limitations right now. Like if you're using the RDD API for Spark, you'll have to change that code to use the data frame API. Or if you're using some of the Spark configurations or the Spark context, some of that won't be allowed in serverless. So you'll have to comment it out, change something. There may be some code changes in Python, but it's likely a lot of your Python code won't need any either. So just give it a shot. It's super simple. A few clicks in a GUI to change to serverless. Yeah, so we were planning a little time for discussion, but I think given that we've got 8 minutes left, we can overlap discussion questions if you think that's a good idea, Ruthie.
Yes, for sure. I would love it if anyone has any questions. You can add them to the comments section. Again, no matter what platform you're watching on, you can add it in the comments section and we'll be able to see that directly on our live stream. And we are wrapping up on time. So if you have a question that you feel like would take a little bit more time to answer, that's not a problem. You can email me directly at ruthie@bpcs.com. That's RUTHIE@bpcs.com. And that way, one of our experts will be able to answer you directly. We can also schedule some time to meet with you if you feel like, hey, your team has more questions that you need help answering. So whatever you like, if you have a questions that you can ask right now, just add them in the comments. We'll wait a moment to see if we have any that come through.
While we're waiting, I would, but in the discussion context, I believe personally, the future of technology is serverless, because at the end of the day, if you have work to be done, this code to run, you honestly don't care how it runs. You just that it runs, that it provides the value. So serverless abstracts away all that lower level stuff that you don't really care about. Another thing I was just thinking about serverless that really, let's say you're on AWS in Databricks and you're all serverless, right? It makes it a little easier if you have to move to Azure. It doesn't it?
Definitely, yeah. That's a great call out. Yeah, you're a lot more portable. I think we didn't really touch on, there's no way we could have touched on everything, but there's more serverless features I'm super excited about too. Like we've done a lot of work in, hey, we've all heard maturity models, right? And at the far right side, super mature orgs, the best practices way to use Databricks is not notebooks. We all know that. But at the same time, how many clients actually don't use notebooks? Almost none. People use notebooks and Databricks. And it's not necessarily a bad thing, right? They've come a long way to introduce things like unit testing and all that. But still, a lot of your standard software development is still, I'm a Vim guy. I don't want to be in a GUI notebook on my browser. I want to be in Vim. I want all my shortcuts and everything else. Well, serverless is giving us this opportunity to say, hey, I can now do this with Databricks Connect serverless. That was part of the blog announcement Monday. So I can do serverless runs of my local code that I'm editing and doing all my testing in Vim. I can do this with Databricks Connect serverless now. And that's a huge change to be able to enable this local dev environment now. I'm excited about that. But IDE wars, everybody's got their own opinion. I'm sure some people love the Databricks GUI.
I'm excited about doing local development in my own IDE. It's kind of in infancy, or maybe it's gone from its infancy. It's like a small child. But when it gets that teenage years or something, or even adult, it's going to be just the way everyone's doing it.
Exactly.
It'd be hard to not,
Yeah. Let's see. Looks like some questions around LHO. We can grab the link. Ruthie may have it handy.
Yes, but, I'm adding it in the chat right now for anyone who would like to learn a little bit more about LHO, what we shortened for Lake House Optimizer. Mm-hmm. And if you have any questions about that, you can hop onto our website, bpcs.com, and we have the drop-down menu underneath Databricks that allows you to go to that page right away, and you can watch videos of how the dashboard looks, how it works, and you can also schedule a free demo, and you will meet with our awesome team who can walk you through the whole process and get you set up in your space as well. So if you have further questions, again, you can always email us at info@bpcs.com. You can email me directly at ruthie@bpcs.com. Any of us are on LinkedIn, or all of us are on LinkedIn, and we'd love to connect with you further if you have questions, or if you just want to connect and be in touch about any upcoming events that we have. Feel free to follow us on our LinkedIn. That's where we post most of our events on, and we make sure to have a LinkedIn Live for all of our webinars. We can also check it out on our website. And we do have some upcoming webinars that I'd like to mention. The first one we have coming up is our part 2 in the series of Gen AI. It's a big topic. Everyone's talking about Gen AI. And I'm going to add that link into the chat right now. So if you have any questions around this, come prepared, because again, it's a live session. Q&A is highly encouraged. And this one is part 2, which is going to be on transforming your HR operations. We have part 3 coming up later in August, and that one will be on transforming your finance department. The first one and part 1 was about transforming your sales department or sales teams with Gen AI. Again, I'm posting this one in the chat, so if you like to learn a little bit about about Gen AI, we'd really encourage you to join this webinar. That one is going to be led by Managing Director of Technology, Gary Nakanalua. He was also a speaker at the Data and AI Summit. So it's a real treat for you to be able to ask him questions live. Great opportunity, take advantage of that. And then we do have another one coming up at the end of August. So stay tuned for that one. But it's going to be about Unity Catalog. It's another big topic with Databricks. And by now, a lot of people have already transitioned to Unity Catalog. And so this webinar is around, well, I'm on Unity Catalog, now what? So if you have questions about that webinar, again, you can email me, ruthie@bpcs.com. I want to give a big shout out to our awesome presenters. Thank you so much, Corey and Steve, for putting this presentation together. And a big thank you to everyone who joined. Taking time out of your day, especially when it's a busy Wednesday, we just really appreciate it. So thank you all for joining. We hope you have an awesome rest of your day, and we hope to see you next week on our Gen AI webinar. Thank you, everyone.
Thank you, Ruthie.